Welcome to Brain Vision.
So question 70 shows us three force diagrams, each one involving a car, and we have to indicate as many situations as possible for the car in terms of its velocity and acceleration at that instant for each diagram. And so let's just draw each of these situations out. So we've got A, B, and C, where we have a force of gravity for each car, and a normal reaction force for each car. And we're going to assume that these forces are balanced. There's a further force of friction, which acts to the right in A and to the left in B, and also acts in C, acting to the left. But C also has the force of air resistance, acting to the right. And so let's discuss. So first of all, what we're seeing here is a car that's definitely on a surface, as the forces up and down are balanced. And we've got a force of friction. Now, for a car, the force of friction is what is involved with its tyres. And the fact that the tyre doesn't slide is what allows the car to move. And hence, this car is actually accelerating to the right. And hence, its velocity goes to the right as well. And the converse can be said of the left. Actually, I've made one small assumption there that I shouldn't have made, which is that the velocity goes to the right. It doesn't necessarily. We can definitely say the same about acceleration, but we don't know anything from a force diagram about an object's velocity. However, it is distinctive in C that we do. We are getting a force of air resistance, and air resistance is only ever going to happen if we are moving in the direction that is opposing air resistance. And so we should see an acceleration to the left here, and a velocity to the left. So what we are seeing is, in the first one, we have a car accelerates, car acceleration to right. So it's accelerating while moving right. Alternatively, so it's accelerating moving right, but also it could be decelerating if it's moving left. We should take into account both of these. Okay, and a similar situation is going on for B, but in the opposite direction. So acceleration to left. So it's either accelerating while moving left, or decelerating moving right. And I know my handwriting's a little bit choppy. It's just one of those things, I'm afraid, for writing on a computer. Now for C, it's interesting. It's moving left. But based on the fact we've got balanced arrows on either side, we're actually going to make one more statement, which is that it's got a constant velocity. For these two, we don't see any air resistance, so we're either neglecting it, in which case we assume there is no air resistance, and in which situation it is accelerating in the direction that we say, and hence moving quicker or slower depending on the situation. Both are valid. Both of these situations are valid. It could be moving through a vacuum, either moving right and accelerating, or decelerating and moving left for A, or in the case of B, accelerating and moving left, or decelerating and moving right. But with the balanced arrows that we have in C, it's definitely moving left. We have to say that because the air resistance is opposing motion and it's travelling at a constant velocity if these arrows truly are a representation of it being balanced. So these force diagrams are quite interesting.